Hello all, welcome you back for yet another episode on petroleum refining. In the previous episode, we have seen how various equipments are used and what are the different maintenance strategies employed inside a refinery. Today, we are going to talk about the quality control aspects, how the quality of each product is determined with the help of a quality control laboratory. In this episode, the contents we are going to see are the products and their specifications, the different samples that are sent to a quality control lab, how the testing are done at the quality control laboratory, the certificate of quality and the various samples that are being tested inside the quality control lab. As we all know that various petroleum products are produced from a refinery by distilling the crude oil. Some of the key products are starting from their boiling point range. The lightest are LPG, naphtha, gasoline, and the middle distillates are kerosene, aviation turbine fuel and diesel. The heavy ends are lubricants, paraffin wax, fuel oil, asphalt and bitumen. So, while running the refinery, these products are continuously being produced, but it is not enough to take them to market. So, all these products need to be thoroughly tested as defined by the standard bodies. In India, we have the Bureau of Indian Standards that has given specifications for each of the products. So, in the refinery, so many products are being produced and then they go to their respective storage tanks. In the storage tanks, the products get collected and once the tank is full, then they are routed to another tank. So, once the tank is full, now this tank can be tested and once the testing is perfect, then it can be taken to the market. The contents of the tank can be taken to market. So, how it is being done? For every product we have a specification. The specifications have specific values and engineering units and the cap, minimum and maximum, and each of these tests signifies certain functionality of the product. For example, certain properties denote how the product need to be handled. For example, flash point is very much essential to know how the product can be safely handled and stored. For example, octane number of gasoline is a perfect octane number is important to know whether the engine is going to have some knocking or not. So, for every product we have a key test that are defined by the standard bodies, but it is not only the key test. For every product or every batch, complete test is done by the quality control lab as defined by the standards. And once the tank is full, the samples are taken using a special apparatus known as sample thief. The operator will go on top of the tank where the tank is full, he will open the dip hatch and insert this sample thief, and using this sample thief you will be able to collect the samples at different levels. This is how a sample is taken on the top of the column, and what are all the samples that are taken inside a tank? They are known as TMB sample. So, TMB is actually an acronym for top, middle and bottom. So, from the for example, if the tank is 3/4 full, then the top portion if you take a sample, then that is known as top sample. In the mid segment of the tank you take a sample which is known as middle sample, and almost at the bottom of the tank you take sample, then that is known as bottom sample. So, like this at different elevations the samples are taken and then finally these are sent to the laboratory, and the laboratory does the testing. The quality control laboratory plays a very vital role in continuous operation of the unit, and it allows the refinery to pump out the products to be dispatched to the end customers. Inside the lab you have technicians who are at different skill level. So, once a sample arrives, the lab supervisor will allocate the samples to the technicians, and the technicians would perform the test as defined by the standards, and finally enter the values in the register, and these details are continuously conveyed to the process group which is running the refinery. So, if at all if the laboratory gives a result which is not acceptable, then accordingly the process parameters are adjusted in the process plant. What are all the different kind of tests that are being performed in a quality control lab inside a refinery? The very first one is a flash point. The flash point of a fuel is the temperature to which the fuel must be heated to produce an ignitable vapor air mixture above the liquid fuel when exposed to an open flame. So, primarily this is the temperature at which the vapor and air mixture is going to create a flame. So, for example, you may continue to heat it. So, at a different temperature level, the air vapor will not get a flame, but at a particular temperature the air vapor will get the flame. So, that is the tipping point. So, this is primarily an indication of safe handling of the fuel. The most common procedure used for determining the flash point of the fuel is the ASTM D93 IP34 test method. In practice, flash point is important primarily from fuel handling standpoint. Then density. For every product, the density is an important factor. The density of the fuel is a measure of the mass per unit volume. The market price and the tax amount are subject to density or specific gravity of all oil products such as crude oil, heavy oil, light oil, kerosene, gasoline and lubricants. So, generally the oil accounting is done on a mass basis, not on the volumetric basis. So, most of the time we will directly calculate the volume stored in a tank, but unless we know the density, we may not be able to arrive the mass stored in the tank. So, in order to calculate the mass stored in the tank, the specific gravity is an important, and today there are sophisticated instruments through which you will be able to find out the specific gravity or density of a petroleum product in less than 1 minute. Color of a product or intermediate stream. The general appearance, color and clarity of a distillate fuel are useful controls against contamination by residual. For example, if fuel oil is contaminated in diesel, then the diesel will look turbid and it will look blackish. It cannot be taken to market. Similarly, if diesel is mixed with the kerosene, then the kerosene color will be yellow. So, it will not be accepted as kerosene inside the market. Although the small amount of water or solids required to produce an unsatisfactory hazy fuel is usually insufficient to affect the performance of the fuel, the customer acceptance is very much important. So, what we are trying to say is, so even if it is slightly contaminated, it may not affect the performance, but the mere appearance will not allow the customer to accept the fuel as a product. So, color need to be tested. It is one of the common tests for most of the products. Then the cold properties. The cold property testing for petroleum products refer to some of the test methods, starting with cloud point, pour point, cold filter plugging point CFPP and freezing point. So, these are all some of the important tests, because most of the petroleum products or lubricants, they are taken to high altitudes or a place where the temperature will be sub-zero. Those places the fuel or lubricant should not freeze or it should not stop flowing. In order to address those issues, these kind of properties are being tested. For example, cloud point and cold filter plugging point are commonly used in fuel testing, while freezing point is tested in the aviation fuel industry. So, aviation fuel, the important test is its freezing point, because the flights will be operating at an altitude of 35,000 feet level. At that particular elevation, the aviation turbine fuel should not get frozen. and the pour point is a specific test for new or used lubricants or greases. Then distillation is an important test that is performed for crude or gasoline or some other petroleum products. In medium and high speed engines, distillation characteristics of a diesel fuel exert a great influence on its performance. Distillation characteristics are measured with the procedure ASTM D86. So, in this continuous distillation apparatus, the sample is taken, it is heated and the hot vapors are cooled and condensed, and the distillate is collected in a measuring jar. So, at a specified intervals of the volume collected, the temperature is noted, and that will determine whether the product is accepted and whether the product can be considered to be on spec. Octane number, I think most of us are familiar with this particular keyword pertaining to the gasoline. So, an octane rating or an octane number is a standard measure of an engine or gasoline capability against compression. The most common type of octane rating worldwide is the research octane number, or in short called RON. RON is determined by running the fuel in a test engine with a variable compression ratio under controlled condition and comparing the results with those for mixtures of isooctane and N-heptane. So, isooctane and N-heptane are the extreme octane numbers, and when you take a sample, we are trying to figure out whether it is being compared with a specific mixture of isooctane or heptane, and finally the octane number is reported, and it is done using the octane engine. Cetane number is for diesel, like how octane number is meant for gasoline. Cetane number is an indicator of the combustion speed of the diesel fuel and the compression needed for ignition. It plays a similar role for diesel as octane rating does for gasoline. The cetane number is an important factor in determining the quality of the diesel fuels, but not the only one. Viscosity is an important property that is being tested for most of the petroleum fractions. The viscosity of a fluid is a measure of its resistance to deformation at a given rate. In order to identify the viscosity, a viscometer or a viscosimeter that is used. In order to measure the viscosity of a petroleum fraction, a viscometer or a viscosimeter is used. Viscosity and viscosity index are important properties of lubricants. Viscosity is also measured for other fuels such as diesel, fuel oil, etc. Apart from manual testing of several petroleum fractions using specific gadgets, there are certain apparatus which can do the testing in an automatic fashion. So, the technician has to just insert the particular sample and then switch on the machine. So, once the test is completed, all the results are displayed in the screen or sent into the computerized system. So, today such kind of sophistication is happening in the quality control laboratory of refineries, and more automated test apparatus are being put to use. So, apart from the laboratory analysis, there are online analyzers inside the refinery. Why at all we need online analysis inside a refinery? When you send a sample to a laboratory and to get the results, it is going to take time. There will be huge latency to know the results of a particular stream. By that time, the refinery would have produced off-spec material or material that does not meet specification. And when it reaches the storage tank, then the storage tank contents will become off spec. So, in order to avoid these kind of issues, today more and more refineries are using online analyzers. So, by having an online analyzer, in real time you will be able to know the product specifications. So, not only this, online analysis are also made available when the products are not stored inside the storage tank, but directly fed to a downstream unit. So, if the refinery is upset in terms of the process control and the refinery is upset and finally off-spec material is produced, which is fed to the downstream unit as a raw material, then the downstream unit will also be upset. So, in order to avoid that, more and more online analyzers are being employed in a refinery. Of course, online analyzers are quite costly, and to maintain the online analysis we need trained and skilled manpower from the instrument maintenance department. So, as I said, the tank samples, top, middle, bottom samples are sent to laboratory, and depending on the product, depending on the standards specified by the standard bodies, the laboratory will be doing a complete analysis. Once the sample is tested with all the test results, and if all the test results are okay, then that particular batch of tank is known as on-spec material, and once the on-spec material is available, the laboratory is going to give a quality control certificate of quality. So, this certificate of quality will have a batch number, and based on that the transfer of products can be effected. In case of any problem in the consumer end, always this particular batch can be referred with the help of a batch number. So, as I said, the quality control lab plays a crucial role in testing all the products, and for each product there are multiple tests, and only when all the tests are clear, then that particular batch is given a batch number. So, if not, then the particular batch is known as off-spec. So, if at all if a tank is found to be off-spec, what can be done? So, it can be adjusted by producing high quality material and then blending. For example, a particular batch of gasoline, the specification for octane number is 90, but that particular batch has got an octane number of 85, then it can be mixed with an octane number of 92 or 93, and then the final product can meet the expected specification. But the problem here in reblending is effort and time. So, we have to put lot of efforts in doing all the reblending, and once again the final sample need to be tested in the lab. So, this is going to affect the steady state operation of a refinery unit. The next way, if at all if blending is not possible, then we have to reprocess. For example, H2S presence in LPG is a test for LPG product. In case if H2S is present, then even if you blend it with a pure LPG, it is not going to get diluted. So, here the only way is to do the reprocessing. The off-spec LPG will be routed back to the amine treating unit or Merox treating unit, and the HTL will be knocked off. But again this is going to take time and effort. You have to, when you are doing reprocessing, then the particular plant throughput may have to be reduced, and then lot of efforts are involved. Then what if the quality is excess? There are certain industries where the manufacturer can afford to give excess quality, but in the refining industry, if at all if you give excess quality, that is going to tell upon your profitability. So, if you for any reason if you give excess quality, then it means it is eating the profitability of your business. This concept is known as quality giveaway. Sometimes the refineries will give excess quality because they may not have time to do a reblend and then resampling, because a tanker may be waiting in the port to take the load of a particular consignment. So, if the tanker is unnecessarily waiting there, then the shipping company is going to charge a demurrage from the refinery. So, the entire logistics of the refining product movements need to happen in a seamless fashion. If it is not happening, there is a huge delay in pumping out the product, then the refinery is liable for demurrage. So, in such circumstances, if we have produced excess quality material, then you will not have time to do the reblending, and then you will be pumping out the material. But ultimately, the refinery is going to take a beating in terms of profitability. So, as we have seen, whenever a tank is full, then we send a sample for the complete analysis, and the complete analysis is okay, then that particular batch is pumped out to the end customer. But in case if it is off-spec, then it is going to be a surprise, and it is going to result in so much of time in reblending or reprocessing. How can this be avoided? So, instead of waiting for the tank to get full and send the sample to lab, what if we send this sample from the refinery at a specified interval? So, these samples are known as intermediate samples. For example, the kerosene or diesel or gasoline from the process unit, they are sent once in a shift to the laboratory to know whether the process control is appropriate inside the plant. These kind of intermediate samples will not be exhaustively tested, but they are tested only for the key parameters. It is assumed if the key parameters are okay, then it is assumed that the plant is functioning smoothly, and only the final sample from the tank will be sent to the laboratory. So, this is the idea of intermediate samples. The purpose of intermediate sample is to reduce the surprises once the tank is full. So, not only the quality control lab is testing the finished products, the quality control lab is also testing intermediate products, and it is also testing the raw material, that is the crude oil. So, the crude oil is tested thoroughly, and the results is known as crude oil assay. This is to ensure whether the crude oil is suitable enough to be processed inside the particular plant. Apart from products and raw materials, in a refinery, lot of chemicals are being consumed. These chemicals are also tested for their purity, their strength, etc. And finally, the refinery is also generating lot of effluent. In the previous episodes, I was mentioning about the effluent treatment. So, the effluent before let out inside an aquatic body, they need to be tested, and the results need to be shared with the pollution control authorities. You cannot afford to let out the effluent as it is without sampling it, without analyzing the content, the chemical constituent of the effluent. So, you have to thoroughly test it, and then only let out in the any of the aquatic bodies, and also these details need to be shared with the statutory authorities. So, while effluent testing is happening for the liquid effluent, ambient air is also continuously monitored, and it is all done with the help of a mobile air monitoring unit. So, generally the quality control department takes care of the mobile air monitoring unit, and continuously report constituents of the ambient air, whether the ambient air has got pollutants like sulfur dioxide, carbon dioxide, carbon monoxide, the nitrogen oxides. So, all this data will be shared with the statutory authorities. Then, to handle all these activities of the quality control lab, we have a software system known as LIMS. LIMS stands for Laboratory Information Management System. So, it is a exhaustive software that takes care of the sampling, the work assignment to the technicians, and defining the on-spec and off-spec criteria, and also the consumables inside the laboratory like the test tubes, the chemicals, acid, etc. So, with the help of the LIMS software, today the functionality of the laboratory is greatly enhanced. So, what have we learned today? In summary, we try to understand the vital activity performed by the quality control lab inside a petroleum refinery. We try to know about the products and their specifications, and how the sampling is done, and the different functionality of the quality control lab. And we also try to understand about the certificate of quality, various samples tested, and a quick note on the laboratory information management system. So, with that we conclude today's episode on quality control inside a petroleum refining. With yet another episode on petroleum refining, we will look forward to meet you. Thank you for watching this.